Hello everyone, welcome back to another Unreal Engine tutorial on the CG Lounge YouTube channel. In this video, I'm just going to be teaching the basics to get started with blueprints in Unreal Engine. So a blueprint is really just C++ in Unreal Engine. It's just that it is visual, so it makes it easier for artists to program in Unreal Engine. So in Unreal Engine, anyone can get started working with blueprints by creating a blueprint class. So if you just right click in the Explorer, you'll have it right here, blueprint class. You can also go over here and find a bunch of other stuff related to blueprints. And like I mentioned, blueprint is pretty much just C++. So this is following the whole object-oriented programming concept. So you have the main class and you can make children off of that class, which inherits from the parent. So this next thing is a blueprint function library. Here you can essentially make a bunch of functions and implement them in your blueprint classes, so then you can just call those functions without having to recreate them. Here's a blueprint interface. A blueprint interface allows you to essentially have multiple blueprints communicate with each other. Blueprint macro library is similar to the blueprint function library, except it holds macros. Enumeration, essentially a variable type. Let's say, for example, you want to have a light switch in your architectural visualization scene. Let's say your light will have 3 states, on, off, and red color. Typically, you might want to store that information by using an integer, for example. 0 is for off, 1 is on, and 2 is for red. But then you're going to have to remember the whole key, like that 0 means off. So that's where an enumeration comes in. Like it says, it is a list of named values. So for example, if I just create this right here, I'll just keep it the default name. I can add an enumerator, and what I can do is I can call it off, I can call it on, and I can call it red. So instead of using an integer variable, I can just use an enumerator instead. And the next thing you have is a structure. I am not going to be going over interchange blueprint pipeline base because that is quite advanced. Structure is pretty much just a collection of variables. So if I make this real quick, what you'll notice is I can add more variables and I can change the type to be whatever I want. I can even add the enumerator we made. So if I just type in new user defined enum, I can have that in here, and I can change the type. I can have it be just a regular variable, an array, a set, or a map. That is pretty much it. A struct is just a collection of variables that can be used within blueprints, just like the way enums or enumerators here can be used in blueprints. Let's get started. I am going to first create a blueprint class, and Unreal Engine has a bunch of classes you can have your blueprint class inherit from. There's an actor, which, like it says over here, is an object that can be placed or spawned in the world. So it's pretty much the most bare bones thing, and all of these can contain logic. So I can have, for example, a ball in a world, which jumps every 10 seconds. A pawn is pretty much an actor that can be controlled by a player. A character is pretty much a pawn, except it has more features. Like a character has this movement component built in, which has the ability to set movement mode to flying, swimming, running, etc. Player controller is exactly what it says. Game mode base is where you define your game mode rules. You can put in logic in here to, for example, in a multiplayer game, you can count how many deaths a player has and give the enemy team a score. Actor component, it's basically what it says over here, a reusable component that can be added to any actor. So it's similar to that character component I said, that character movement component, where you can give it a bunch of functionality, attach it to another actor. Scene component is pretty much nothing. Like it says, it just has a transform. For now, I'm going to make an actor, and we'll call this my actor. I'm going to double click to open it up. What you'll notice is there is nothing. So if we were to drag this into our scene, we will see nothing. And that is because we need to add components to it to give it a representation. So here's where we would add a component. And if we were to create this actor component here, we would be able to add it over here. And that is where, like, let's say in the actor component, I create some logic in here where I say jump every 10 seconds. If I just attach it in here, this actor blueprint would start jumping every 10 seconds. And that's what's neat about actor components, because you can just put that functionality to multiple actors without having to recode anything. Okay, so let's just start off by giving a visual representation to this blueprint. I'm going to start off by pressing add, and then we can add a skeletal mesh, which is pretty much your typical mesh that has bones. So a rigged mesh. We could put a static mesh, which is a regular, just a mesh. Or we could put in any of these preset shapes that come with the engine. So I'm just going to put a sphere. So now if I hit compile and I minimize, the sphere is now in the scene. So if I press play, we will see it floating over here. Now let's give it some functionality. So most blueprints come with all these nodes. We have begin play. This is what gets fired off once the game starts. We have this node here, event actor begin overlap. This gets called whenever something overlaps with the actor. So if something were to overlap this sphere over here, this would get fired off once. And you can also, let's say for example, we have two spheres, right? Let's say by default, if either one of these spheres get overlapped, this thing will fire off. Let's say we only want this sphere to overlap and fire off, but we don't want this one to fire anything off. We just wouldn't attach any logic to this. And instead, we would select the sphere, and then we would right click, add event, collision, and then add on component begin overlap for sphere 1. So I'm just going to delete that. Now, another thing to keep in mind is if you want stuff to overlap, you're going to have to go to the collision and allow it to be overlapped. So right now it's set to block all dynamic, so it's just going to block everything. So as you can see, it is blocking everything, even the player. If we want it to be overlapped by the player, we're going to have to set collision presets to be overlap all. You could also just choose custom and tick your own boxes. So I'm going to hit compile, and now we should be able to overlap it, as you can see. And this next node is event tick. This gets called every frame. So most of the time you don't want to use this if you're worried about performance, but in very specific cases you will find yourself needing to use this node. All right, so now that I've explained the default nodes, let's go over the anatomy of nodes. So pretty much all nodes will have this arrow looking pin. This is called the execution pin. This basically controls the flow of logic. So let's just say I'm going to put a branch here. So on begin play, the flow of logic will go through the branch, and depending on the condition, the logic will either flow through the true or the false branch. Okay, before we continue, I would like to give a short explanation of what variables are. So variables are essentially containers which store data. So there are multiple different types of data that can be stored. The main ones that you will most likely be using are right here. So we have a Boolean variable type. This essentially just holds a true or false value. A byte is exactly what it says here, just an 8-bit number. You most likely will not be using this. An integer is exactly what it sounds like, it's just a number. It only holds whole numbers, so 1, 2, 3, 4, 5, -1, -2, etc. This integer variable you will find yourself using quite often. Integer 64 can essentially hold larger integer values, but it also takes up more space in memory. A float is basically an integer, but it can have decimal points. So you can go to 1.015 rather than just being restricted to 1 or 2. Name is just a variable type that can store characters. For example, if I just create this variable here, and I can set the default value to be a bunch of characters. String is also similar to the name variable in the sense that you can store a bunch of characters in it. Text is also like name and string in the sense where you can store characters inside of this variable. But do be aware, even though these variables appear to be the same, each of these variables have different functions that can be run from them. So for example, let's say I'm making a widget. If I were to have a text in the widget that I want to set, I am forced to use a text variable type. Now again, strings can be converted to text and vice versa, but that is just an example of how in some cases you will be restricted in what variable you can use, despite names, text, and strings performing essentially the same function from the surface. The next variable you have is a vector. A vector essentially holds 3 floats. So if I create this and compile, you'll notice that there are 3 different values I can set, x, y, and z. But yeah, all you basically need to know is that a vector is a variable type that consists of 3 floats. It can be used to describe location, velocity, among other things. Next, you have rotator. Rotator is similar to vector in the sense that it consists of 3 floats. The only difference being is that rotators are usually used to not describe a location, but the rotation of an object. So if I make this and compile, you'll notice that there are still 3 floats. And notice how I've been saying 3 floats instead of 3 integers. That's because you can set a number with decimal points in here, and you are not just restricted to a whole number. So the last variable I'm going to be covering is a transform. A transform is pretty much just 3 vectors combined. So if I just quickly compile this, what you'll notice is that we have 3 vectors, each describing what it's responsible for. So the first vector is responsible for describing the location. Second vector is responsible for describing the rotation. And the third vector is responsible for describing the scale. Now this is useful in cases where, for example, you want to spawn an actor. I'm just going to create a quick little example here. So I'm going to put spawn actor. What you'll notice is that it takes in a transform. By putting in this transform, you can describe where you want this actor to be spawned through the location vector. You can describe the rotation of the actor when it spawns, and you can describe how big or the scale of the actor when it spawns. Some nodes will also have these other output nodes. As you can see, this one is called other actor. This outputs an actor object reference. Now you might be thinking, what if a character were to be overlapping it? Would a character still be outputted? And the answer to that question is yes. That is because blueprints use object-oriented programming, and an actor is the parent of a pawn and a character class. You can think about it this way. A character is an actor because it is deriving from a pawn, and a pawn derives from an actor. So in a way, a character is an actor. So if a character were to overlap, a character would be able to come out of this reference, except it would come out as a form as an actor object reference. It won't come out as a character object reference. Basically, characters can overlap and they will be outputted here, but they won't be referenced as a character. They will be referenced as an actor. So depending on the node, you will get different outputs. This one outputs an actor object reference. Some nodes will also give you floats, and some nodes will also receive inputs, such as this branch here, which takes in a boolean. So let's quickly program an example. Let's utilize begin play and begin overlap. So for my example, I want to show when this gets executed. I'm going to call a print string, and it's just going to say hello on the game start. As you can see on the top left, it says hello. So yeah, this gets called once the game starts. But let's go ahead and add some code for when let's say when something or someone overlaps it. So let's say when something overlaps it, we want to have it move up just by some random number. So to do that, what we first want to do is we want to get the location of itself so we can add onto that, right? To get location, it's actually pretty simple. Just type in get actor location, and then return value will return a vector. And as you can see, this returns the location of the root component of this actor, and the root component is this scene component. So after we get the value, what we want to do is store it in a variable. So you can come over here to create a variable, name it, set the type and whatnot, or you can just right click and then promote to variable. And then we can just name this. And By default, if we just do this, it's not going to set it. So we have to connect the execution pin. So now once we overlap it, it's going to set it. So now that we have stored the initial location into the variable, we want to now move it up. So what we can do is set actor location and connect the execution pin to it. So this is what gets called next. Target itself, because we want to move this actor. We could obviously move other actors. So let's say we get the actor that overlapped this actor. We can move that actor, which we don't want to do, but the option is there. So now we want to set the location to be this new location. So what we're going to do is get the initial location, and we're going to drag it from here, get the variable, drag off of the output pin, type in plus to add, and here we can add on the Z value. Let's just type in 25 and then drag this into the new location, compile, and now let's see what happens. As you can see, it's shifted up. That might not have been obvious, so I'm going to bring it up to 75. I'm going to move this down. There we go. So as you can see, it's shifted up, and because of the way we have it set up, if we overlap it again, it is just going to keep moving up. So first overlap, it gets the location, adds onto the current location, then sets that new location. If we overlap again, it's just going to run through and do the same exact thing. So let's overlap, back out, overlap. Now it's higher. Now at the moment, if any actor overlaps it, it's going to move up. So let's say we want to add a check, right? So for now, I'm going to press play to see what blueprint we are controlling. So it seems like the blueprint we are controlling is called myCharacter_BP_comms. So let's say we want to add a check so that only the character we are moving is able to move the sphere up. We would drag off this and set cast to myCharacter. So now it's going to try casting to it. And remember how I said every character is an actor? This is why we are able to cast to this character. If we were to have another blueprint whose parent is not an actor, we wouldn't be able to do this. So now we can drag off of this. If it is successful, it will continue to do everything else. If it fails, we can just print string and say not the player. What you'll also notice is you get a reference to this character you're casting to. Now you might be thinking, what's the difference between this one and this one? Because we're pretty much outputting the same thing, right? Well, by default, we're just getting a reference to the actor. So if we were to look at the code for the actor class, we would essentially have nothing. We just have access to the basic functions, such as get actor location, right? But by casting to this, we get access to this whole blueprint now. This thing has a function called projectile trace. So now we can call it projectile trace, as you can see, which we couldn't do before because that function existed in this blueprint. So by casting, we get a reference to this character blueprint. Whereas before we're getting reference to the actor, not the character blueprint itself. So anyway, now it'll still move up because we are the player that is still overlapping it. But let's say if it overlaps, we want it to do something else. We only want it if it fails, it moves up, right? So we'll just have this one print string. I'll move this one up, and I'll just rename it to player. So now we should get a print instead, player, and it is not moving up. Okay, so that is pretty much it. This should have just been good enough just for the pure basics. So now, from now on, other tutorials you watch, you should be able to pick up fairly easily. There is another video on the CG Lounge YouTube channel. In that video, I show how to make interactive architectural visualization scenes. Check that out if you want to delve deeper into blueprints. It doesn't go in much deeper, but it goes in enough to cover the topic of communication with other blueprints, similar to what is shown in the examples here. But yeah, that is pretty much it to basics of blueprints. If you have any questions, leave a comment down below, or join the CG Lounge YouTube channel. I am much more active there, so I will be able to answer more questions there. We also have other Unreal Engine users in the server who can answer your questions. But that about wraps up the video, and I will see you guys next time. Bye.